will well, thank you all for joining us today, particularly from Australia, Peter, and I notice also from Latvia, Gundas. Nice to see you again, and I'm glad to see that Nida, that Lloyd's Lister paying us a visit today. And so our overall conference chairman, as most of you I'm sure already know by now, is Professor Mike Bradley, who is the Professor of Bulk and Particulate Technologies at Greenwich, the University of Greenwich, and Director of the Wolfson Centre for Bulk Solids Handling. And he's been Director there since 2000 and a Professor at the University since 2006. And I'm very grateful for the fact that he also sits on our ABTO members advisory panel. Bit of interest for the UK delegates. Mike is a competition dancer and qualified in both national, in both ballroom and Latin disciplines at some national events. For those of you, well, one or two I noticed from the UK. Anyway, our chairman today, our session chairman today, is Richard Steele from ICHCA. So I'll pass over to Mike to introduce Richard, and then from then on, Richard will take over the proceedings. So over to you, Mike.
Thank you, Simon, and good afternoon, everybody. I hope you've enjoyed the conference so far. I think we've had some pretty good sessions. Today we continue with more about risk and safety in particular. So we've got three interesting papers from dealing with various aspects in that area. And our session chairman for this afternoon will be Richard Steele. Richard is the Chief Executive Officer at ICHCA, the International Cargo Handling and Coordination Association, an organisation that I'm sure will be known to many of you. Richard reports to the board and he leads the organisation that provides a focal point to improve cargo handling throughout international supply chain. ICHCA represents members and the cargo handling industry as a whole as a recognised non-government organisation at international bodies such as IMO and UNECE and various other agencies and regulatory bodies. So ICHCA has a high standing. Richard is a safety and skills professional. He has a master's in training and development, and he's been involved in the ports industry for over 21 years. So he's been around the block in this area. Before he was with ICHCA, he was chief executive at the Port Skills and Safety, an organisation that he led for 11 years. That's a UK organisation who have the aim of sharing best practice, developing safety guidance and standards and so on, and produce qualification frameworks for stevedores and other people who work in ports. Before he was with PSS, he was a senior learning and development manager for ABP, Associated British Ports, for 10 years. And prior to that, he worked in the nuclear industry on safety and skills provision. So Richard's got a long background in safety and in organisation and so on, and obviously he's in ports and port regulation and such like from several different angles. So I'll pass over to you, Richard, to chair this afternoon.
Smashing. Thank you, Mike. Can everyone hear me okay?
Yep, I can hear you loud and clear.
Brilliant, thank you. So welcome delegates to the Association of Bulk Terminal Operators Bulk Terminals Riga online conference hosted by the Freeport of Riga Authority. So today's day 5 of the conference and the focus really is on safety and risk. ICHCA and ABTO have a long-standing relationship. We've worked together on many occasions, and so I was delighted when Simon asked me to chair this session because, simply put, it's right in our wheelhouse. I think the job that we all have, irrespective of roles and responsibilities, is to work together to make our parts of the supply chain safer. This is not a matter for individual commercial advantage, but to make our whole industry better for those who work in it or are affected by it. By creating the right working environments and systems where risks are managed and people are considered at the centre, we also gain in productivity, efficiency, customer care, reduction in loss, flexibility and adaptability. I passionately believe that good safety is good for people and good for business. And so on to business. We have 3 first-class speakers for you today. Each one will run about 20 minutes, and there will be an opportunity for questions at the end of each session, sorry, at the end of the final session. But if you do have any burning questions, please do put them into the chat and we'll endeavour to get them answered. Peregrine Stawes-Fox is Risk Management Director at the TT Club, and he's first up. Peregrine can't be with us live and has recorded his session for you today. But one of his colleagues, Manos Karanikolas, will be attending and is on screen already to field delegate questions at any point, appropriate point in the proceedings. So Peregrine, our speaker, has led TT's sustained campaigns dedicated to issues including inaccurate gross mass, focusing on trying to improve the packing of cargo transport units and the adoption of the CTU code. He's done a lot of work around tackling misdeclaration of dangerous goods and the resulting impact on container ship fires. And he currently leads the TT Club's participation in an organisation called the Cargo Integrity Group, which is encouraging all supply chain stakeholders to commit to the highest safety standards in packing, handling, communicating information about unitised cargo across the globe. He's been with the TT Club since 1984 and has a vast array of knowledge of transport and logistics operations, ports and terminals. And since 2002, Peregrine has led the TT Club's loss prevention services to members. So without further ado, I'd like to ask for Peregrine's session to kick off. Thank you.
Well, I'd like to add my welcome to everyone joining this webinar and hope you find the session interesting and provocative. In a world that's encountering all sorts of trade stresses and disruptions, let alone geopolitical strains, there are many risks that are being faced. I myself have been with TT since 1984, joining on the claims side, handling a whole range of claims for members with different operations globally, and then moving over to head up our risk management and loss prevention activities in 2002. In terms of what I'm looking to cover, there are a whole range of risks faced by operators of all kinds through the international supply chain and specifically bulk terminals. And here I'm kind of selecting a few, and I've used these generic tabs as reminders really as to what I'm looking at. For those unfamiliar with TT, it's a mutual providing insurance and risk management for interests throughout the global supply chain, including cargo, freight forwarders, MVOCs, ports and terminals, containers, and similar equipment. And obviously in this environment, we do also cover bulk terminals and bulk ports. And it's a mix of asset and liability covers that we provide in a tailored way. And as such, TT sees as its core mission to make the industry safer and more secure. With that in mind, this is a kind of Pareto type chart indicating the range of risks faced by the bulk terminal industry based on cost for the last 5 years. And I'm not really going to go into detail on each of these, but clearly shipping port is a major issue for any bulk terminal because that's where your business, your trade is coming from. But ships regularly hit berths and sometimes trains in calm weather as well as in bad weather. And in bad weather, you can have mooring lines breaking and things like that. And that links in obviously to rain and flood type risks that I'll come to in a bit more detail. Fire is a constant possibility with regard to sort of the equipment you have, as well as the stockpiles potentially. Contamination, wharf crane. I could go down the whole list, but I don't think that's necessary. It just gives you a sense of the sorts of risks that we see on a regular basis. So what are the long-term risks that I'm going to look at? Well, I'm going to be addressing something around the climate change that we are seeing. There are all sorts of things that could be brought out here, and I'm not talking here of something in relation to sort of climate science, but there is a reality that we are seeing more storm-related issues arising. We are seeing the consequences of that on a constant basis, whether you're talking about unprecedented rainfall in Europe, as we saw earlier in this summer, causing significant flooding. But the risks arising from that are around tidal surges, the fact that tides may be higher and cause much more significant damage, not just in the immediate port area, but actually further inland. And of course, that then flows back into the port environment down normal river channels. So we're seeing that as a regular risk. And as a result, I think it is a call to all in the industry to keep assessing what the risk profile you have specifically. And that fundamentally is around looking after your own personnel, your operations, your equipment, as well as the cargo, the property of your customers. The reality around climate change science and sort of meteorological studies is that there are increasing sources of information and data, and I think it would be sensible to link into that and be as alert to what is happening in the local area where you're facing those risks. So I think in this environment, we can't say that it's seasonal storm events. We're not just talking of tropical storms, we're talking about storms arising at all times of the year. And as I've mentioned, the key risk, I think, is around surge and flood, which can impact the berth and equipment, the stockpile, and specifically with regard to bulk cargoes, that can be leading to the stockpiles actually slumping, and also there's the liquefaction issue. And I'm not going to get into the detail around measurement of the moisture content, but it is something that is needing to be taken account of by terminal operators in collaboration with the carriers and the charterers to ensure that safety is maintained and we don't see capsizes and sinkings in the way that we have done historically. And of course, in terms of floodwater, there is the ongoing risk with regard to the dirty and unsanitary nature of wastewater, and that itself may be a specific risk that needs to be taken into account with terminal operations as to where your wastewater is going, how you contain it, how that is managed in an effective and proper fashion for your environment. So in terms of risk assessment, I think these are just some pointers around how you might want to look into the risks that you're facing in the terminal. And of course, it is going to be specific to your operation. So it is, what activities are you facing and how would you be affected in a flood environment in particular? And that's not just looking at the cargo, but it's looking at how people get in and out of the terminal. How exposed are you? what are your exposures to high winds and floods in general sense, and taking account of the weather data that is increasingly available, and ensuring that you're plugging into what is locally available. It isn't what is the condition on some central national database, but actually what is specific to your location. And in relation to the cargoes that are handling, what are the types? How vulnerable are you to the risks arising, both in terms of things like the cargo slumping, but also in terms of potentially fire risks and things like that, as well as dust. So that there are all sorts of issues that are needing to be taken into account in assessing the risk. In terms of this general statement, I think I'd just say, don't replace safety with insurance, or don't assume that insurance is going to pick it up. Place safety first, plan ahead and be prepared, and look for good advice from a whole range of different bodies, including associations such as APTO, around how to mitigate the risks that you're facing. And where there are actions that are needing to be put in place, then actually set in action tests and trials and practices to ensure that you are ready for the risks that might be arising. And just by way of summary on this part, then I refer to the TT Club's own Windstorm 2 booklet, which raises a number of issues and has some practical advice with regard to how to manage terminal environments and how to set up effective emergency plans as well. So moving on to what I've called medium-term risks, and of course this isn't medium-term, but abandonment of cargo is something that we've seen with increasing regularity. And I guess those unfamiliar with this industry might assume that anything that's moving through international trade is eagerly expected and awaited at destination, that there will be a trade flow both in and out of your terminal environment. And of course, the reality is rather different. For a whole host of reasons, cargo may become abandoned. There are, I guess, reasonable causes, such as insolvency of the receiver or loss of market. There are aggravated causes where something gets stuck in a process, possibly related to a regulatory issue. And then what I call dark, which may be illicit trades, counterfeits and contraband. That's probably not going to be so relevant to the bulk industry, but it's something that is of concern through the supply chain. Whatever the cause, those involved in moving cargo face a headache and disruption of inordinate scale. So, yeah, I've covered a number of these here. Practically and contractually, there can be links with those who have an interest in the consignment. But when an alert is raised, everyone is on the back foot, and resolving a problem is most likely to be draining on time and resource for every management. It's going to involve a number of people, not just agents and a maritime carrier, but also the terminal and storage facility, and potentially regulators, often customs, but depending on the nature of the cargo, it could be a lot more complex around safety authorities or even governmental authorities. And apart from the diversion from productive activity, the costs will continue ticking up. It may well be that lawyers have to get involved, lawyers and courts eventually, scrutinizing ownership as well as contractual rights, such as lien or rights to dispose of the cargo. Even without some of the hazards that we're aware of here, this is going to be an unwelcome irritation for your activity. inevitably, experience enables us to identify some of the characteristics that assist you in understanding ahead that there might be a problem arising. For the most part, what I'm addressing here is also covered more thoroughly in TT's recently published stop loss entitled Abandonment of Cargo, Avoiding the Pitfalls, and I commend that to you. But suffice to say, there are red flags that need to be taken account of by the different actors through the supply chain. And many of the things identified here can act directly to put those taking part in the supply chain, from booking to sort of storage to loading to discharging and again storage, need to be taken account of. And of course, some of it is around kind of being alert to wider environmental issues, sort of the geopolitical type issues that need to be taken account of. And I also mentioned sanctions there. Again, that may not be hugely relevant directly to bulk terminals, but it is something to be taken account of. And of course, we're seeing particularly in the intermodal trade, but throughout the industry, we're seeing all sorts of things with regard to disruption arising at this stage, and that will impact operations on an ongoing basis. So moving on to near-term risks, I call it, and here I want to focus on enclosed space fatalities. So what are enclosed spaces? I'm not going to read these definitions. The slide hopefully will be up long enough for you to get that or get it afterwards. One management consultancy who specialises in shipping safety advised that maritime remains considerably more dangerous than most other professions. In the past decade alone, there have been more than 2,500 safety-related incidents every year, with fatal accidents 20 times more likely in maritime and in its terminal environment than in other industries. And I think the main issue from that is creating a culture. Culture within an organisation is going to be central to root out safety concerns from the sort of the worker level up to management and back again, and ensure that new approaches can be installed to protect life and assets. So what are we talking about? Well, here's a range of things, and this isn't an exhaustive listing of places where people are going to be exposed to the possibility of enclosed spaces and the risks arising, and those all need to be accounted for. So, yeah, I mean, these are the places, and in order to enter those places, there need to be proper risk assessments. So, yeah, this is just an example from Lloyd's List a couple of years ago. Oxygen depletion fatalities on the rise, and that has to be concerning that they're on the rise, because you would have thought it's human nature to ensure that those sorts of things are followed through in terms of having the right procedures, making sure that they are followed through. But of course, the reality is that these things happen, and they happen because enclosed spaces are dangerous. They may not just have a lack of oxygen or presence of carbon dioxide, but there will be other things potentially in the holds or in that enclosed space that cause risk to people. So, yeah, I'm going to throw up a couple of examples, and I'm so aware actually that even in the last couple of months, there was another report of fatalities. And the most common issue here is that someone gets into problems and the next person goes down to help them, and then they get into problems, and then the next. And it's quite common to see 2 or 3 fatalities arising because people are just not aware of the risks. And it is so important to be aware of the nature of an enclosed space and the risks that may be presented in order to set up proper procedures to deal with that. And it happens around the world, this one in the UK, but it isn't particular to a trade, a location, a particular commodity, or even a particular type of enclosed space. It is so prevalent, and it's human nature to look to help a colleague, but the issue is actually to plan in advance so that you're able to avoid this happening in the first place. So here are some sort of issues just to summarize really the whole point about having a plan in place. Ensure that workers are aware. Assume that confined spaces are unsafe and therefore restrict access to them, and have a plan to ensure that those who are accessing confined spaces are doing so in a safe manner, that there are procedures, that there are appropriate warnings, whether it is devices or purely ensuring that there are enough people around to make sure that those risks are mitigated. It is a continuous training of staff. And the biggest problem that we see is the human factor, that people will behaviorally want to go and get involved and help. So, by way of conclusion, my timings, of course, here are fictional. It isn't long-term, medium-term, or near-term. Each require attention, and the volume or urgency will differ according to your circumstances. However, I would say that human life, and include there very specifically human behaviours, are critical to the success of any operation. So maintaining a safety culture and understanding where your risks arise is paramount. Hope I've been provocative, hope there are some issues arising, and thank you very much for listening.
So thank you to Peregrine remotely. Sorry. Thank you to Peregrine remotely for that. The first matter of business is to ask if anybody has any questions. Manos is here to field on behalf of Peregrine and TT. So if there are any questions, perhaps you could pop that into the chat. Actually, while people are thinking about that, Manos, I was just wondering, perhaps if you could, if I could throw a question your way, sort of in terms of assessing the risks of climate change or changing climatic conditions, what do you think is the main role of insurance in that activity, that assessment?
Can you hear me, Richard?
I can, yes, thank you.
Okay, good. Thank you for this question. Well, as Peregrine mentioned earlier, there are some areas which can provide a sound basis for assessing the risk, and one of these areas is the insurance, of course. I would say that insurance may provide a degree of protection, but we would have to distinguish between insured losses and pure economical losses, the latter being normally indirect costs, such as reputational damage or loss of management time. We as insurers always advise our members to make sure that the insurer has a solid and sound understanding of all the operational activities that are being undertaken, what cargo is being stored, what equipment a member has, and of course there has to be a reasonable valuation of all of it so that the risk can be properly assessed. The role of insurance is vital, and it's preferable to keep your insurer aware of all your operations so that you can minimize your risks.
Excellent, thank you. Do we have any questions in the chat? Oh. So a question from Mike. Mike Bradley, have you seen more confined space incidents with the rise in biomass transport?
I'm afraid I cannot answer this question, but I can definitely do a research and respond separately.
Okay, that's great. I know that we, when I was doing the work in the UK, biomass was one of the key areas that was driving revisiting confined space work. So I think it would be interesting to see if it's possible to identify whether there's any connection there. But of course, the problem with sort of confined space risks is we've known about them for decades and don't, as a world industry, seem to be getting to a place where we're able to drive them down. So no, but thank you very much, and thanks, Mike, for that question. Just having a quick look in the chat. I'm not seeing any other questions at the moment, so perhaps I could just throw one final one at you, Manos, if you don't mind. The force majeure defence, how easily do you think ports and terminals can rely on that when it comes to these extreme weather events and the impact on their businesses and operations?
Well, as always, we advise our members to include force majeure clauses in their contracts. As Peregrine mentioned earlier, we are seeing changing climatic risks recently, and there have been recent localized incidents in recent years where, for example, extraordinary volumes of water fell over a short period of time, and this resulted in damage to warehouses and the cargo stored therein. This resulted in flash flooding, actually. And somebody would be inclined to immediately invoke the force majeure defense, which cannot always be invoked. First of all, it depends on the interpretation of force majeure clauses when it comes to its jurisdiction. And at the same time, if the party that is bringing a claim against a terminal operator, if this party can show that there were, let's say, inadequacies in the measures that were taken in advance of this event, or that there are deficiencies in the operational risk assessment, then the force majeure defense cannot be potentially invoked. So we have to be very, very careful.
Excellent, thank you very much. I can't see any other questions in the chat, so no. So I will just like to say thank you to Peregrine in absence, and thank you to Manos for coming along. And if you're able to hang fire in case there are any questions at the Q&A session at the end of the afternoon, that would be excellent. In terms of some thoughts that I'm going to take away from what you said and what Peregrine put in his presentation, there's a couple of things here. One about plugging into local data and making sure that you're looking for information that is relevant to you and your situation. I quite like place safety first. Don't assume that insurance will pick it up, which was quite brought a smile to my face. What then took that smile away was the fact that we're talking about maybe 2,000 plus incidents in enclosed spaces every year, some of those fatal, and the situation seems to be that things are getting worse, or certainly not getting any better. So I think it is vital that we apply those sort of targeted risk management approaches to different types of risks and make sure that we've got solutions that fit, you know, the circumstances, not going for a one size fits all approach. So
Indeed,
thank you very much, Manos. Oh, sorry.
As you said, it's preferable to plan ahead and be prepared for the worst case scenario.
Excellent. Yes. And you know, are these things reasonably foreseeable? Well, it is reasonably foreseeable that these kinds of events and activities and risks are present in your environment or at your location. So excellent. No, thank you very much. Thank you for your time and the contribution there.
Thank you, Richard, and I can revert to Mike separately.
Please do. But I think if you can pass it on to Ian or Simon at ABTO as well, I think the other delegates would be interested to hear that too, as would I.
Okay.
Although Peregrine isn't here, I would like to sort of sneak in a quick mention for the TT Club Innovation in Safety Awards, which are on this year. The TT Club have sponsored these awards, which are designed to highlight the importance of safety at a time of increased operational demands. And the goal of the award really is to champion and celebrate the companies and individuals around the world who are 100% dedicated to making it safe every day. The idea with the awards is that if you have an innovation, if any organization has an innovation or a solution or something that is changing the way safety is handled and making the operation safer and more effective, then you can register through the TT Club's website or on the ICHCA website as well, and that's available at www.ichca.com. So without further ado, I think I'll move on to session 2. And with session 2, I'm pleased to now introduce Professor Whippich, Peter Whippich, who will take us on a journey through some leading edge research and case study work in a session that is entitled Application of New Dust Control Technologies for Bulk Loading and Unloading Operations. Professor Whippich is the Director of International Solids Handling Research Institute at the University of Wollongong in Australia. And his areas of expertise include, and there's a huge list here, so I'll just do the first half dozen. Bulk material characterization and flow properties, design and operation of storage facilities and handling equipment, dust control technology, including dust suppression and dust explosion risk and management, simulation and dynamic modeling and design of handling operations and equipment, and a vast array more. Some of the work that Peter's presenting today was developed along with researcher Dr. John Roberts, also from the Institute, and Dr. Renu Pan, Vice President, Fujian Longqing Company Limited. And I'd like to now hand the screen to Peter. Thank you.
Thank you, Richard, and greetings from Australia. I'd like to thank the organisers for the opportunity to talk at this event. But I'd like to also mention that I was advised that the talk would go for 30 minutes, not 20. So if the chairman would like to stop me at 20 minutes, I'd like you to try. Anyway, we'll see how we go. I'll go through fairly quickly. So the talk is about new dust control technologies, but I'd like to, as an introduction, talk a bit about the dust control evolution. So what I mean by that is that traditional approach to solving a bigger dust problem, in my experience, as I've seen around the various parts of industry, is perhaps to go for a bigger baghouse. This is a fairly common approach. And with a bigger baghouse, you need a bigger fan. And so here we see a typical installation on a fairly large facility, and the incoming duct here onto the baghouse is big enough you could actually walk through if it's clean. And you could imagine the sort of size of fan that you would need to run such a system. In this particular case, I think from memory, the fan's over 1 megawatt installed power. And just to run that fan over a year would be of the order of in excess of $1 million Australian dollars. So yeah, the bigger the dust problem, the bigger the solution, and of course, the bigger the cost. Or the other way to do it is, of course, put a lot more water onto the problem. And so these sorts of water cannon installations are quite common, as I see around the world, and particularly in Australia. But, you know, you start to question, when you look at the size of some of these cannons, you know, they can be 80 millimeter diameter, you know, at 6 bar pressure, and you can imagine the amount of water these things spew out. And if you start to tally up the amount of water you lose in a year, you're talking about the order of millions of gallons. So water usage, if you've got more of a dust problem, add more water to it. Yeah, of course, that's a fairly traditional approach. But I'd like to share now with you a more advanced or modern approach to dust control. And so the first thing we need to think about here is to understand and quantify and model the problem, which involves a whole range of technical issues. And I do warn you, this talk is a fairly technical one, but I'd like to throw as many case studies as I can in there to keep the interest there. So we have air entrainment issues, dust generation, dust emissions, and so forth, fairly complex mechanisms. We also need to know about our bulk material, of course. Things like dustiness and dustability become important from a dust control perspective. And also, we've got to start thinking more about, instead of treating the symptom, actually identifying and targeting the root cause of the problem. So using new technologies is the next step. There's been a lot of developments in this area to develop optimal solutions in terms of hardware, modeling design software, and also, very importantly, something that can be implemented to a lot of existing installations is in pursuing intelligent dust management systems to optimize or minimize the amount of water, for example, that you need at a stockyard. Now, the other thing we have to keep in mind too, that dust problems are actually physical science problems. And so if we do seek a solution to a dust problem, this also must involve physical science to some extent. So if we don't get the science right in this particular case, in these sorts of problems, then the engineering design solution can be incorrect or certainly far from the optimal. So we do need to invest in R&D of new technologies to solve industry's big dust problems. So in my presentation, I'd like to summarize some of the key achievements in dust control technology. I'll talk briefly, firstly, about total particle treatment, and I'll explain what I mean by that in a moment. But secondly, most of my time will be focused on airborne dust suppression, which we've used quite a lot in some of these bulk terminal installations. So firstly, with total particle treatment, we have what we call, one option is product wetting, similar to the water cannon approach I showed you earlier. So for this type of technology, we need to look at the dust moisture relationship. And to quantify that, we need to do some dustiness testing and determine what we call the dust extinction moisture content. So one example of that is I've showed you previously, the water cannon, just adding water to the problem. But the question is how much water? And that really does depend on your bulk material properties. Even for coal, from one coal terminal to the next, the amount of water you need can be quite different based on different coal properties. And the second approach to total particle treatment is what we call dust suppression formulations. It's more of a chemical solution approach where we treat the fines so that we don't liberate fine dust when we handle the product. So quickly, dust moisture relation is pretty important in this area. And there are two standards around the world that I'm aware of. And in Australia, we use the Australian standard and also the international standard. And we've done a fair bit of work to compare the two, and the results are different, unfortunately. So dust ain't dust, so to speak, according to different standards. But I haven't got time to go into it. I have published in that area. But that's just to show you what these things look like. So firstly, with the Australian standard, it's just a simple rotating drum tester. We put a certain amount of coal in there. That's dusty, of course. and we bury the moisture of that product. We rotate it for a period of time at a certain speed, and we extract, we suck some air through the drum, collect the dust, and we measure the amount of dust. So it's a fairly simple test. We repeat that for different moistures, and we come up with what we call a dust curve. So here we see some typical results for black coal, and you can see on the y-axis here the dust number, which is a direct measure of the dust that's being captured, versus the product moisture. So with all the coal types, you can see as we increase the moisture, the dust number or dust emission or dustability decreases. Now, in the Australian standard for coal, when we reach a dust number of 10, that's when we consider the bulk product can be handled without causing a dust problem. So that's the number we seek from a dustiness test and from an operational perspective. And now what's interesting here, we've got 5 different coal types, all black coal. And you can see in one hand, if you are handling the blue coal, over here, your dust extinction moisture content is about 6% water. That's what you need. Whereas with the black coal on the right here, you need 26%, 4 times more water. So if you don't know what these numbers are from an operational perspective, you could miss the mark by a huge margin in terms of controlling your dust by adding water to the product. So moving on. So just a quick demonstration of dust suppression formulation, something that we worked on a few years ago on an iron ore mine. Here we see the stacker, a schematic view of it, where the product then is picked up by front end loader and then put into trains and road trains and trucks, which is then taken to port. Now, this particular mine has a very fine iron ore being produced, and even with the water sprays at the end of the stacker that you can see there, and even with addition of water trucks, you can see they're having great difficulties controlling dust here. So you could say, yes, they do have a dust problem. And you can walk around on the ground here, and you're 3 inches deep of bull dust, I call it. And it stays fluidized for weeks, and the stuff is very fine and fluffy, fine and fluffy, and very, with any wind, the stuff gets airborne very easily. So it certainly makes a lot of sense to try and do something about this product before it gets to port. So by quantifying, we can start to see what's possible. So with just water, just wetting the product with water, we can see that the relationship here is not linear, as we saw with coal. So the dust number versus the total moisture. And so we've got the dust number with water. Now with a chemical formulation, we have a different dust curve. So the target here is a dust number of 10. So in one case, just with water, you need 11% wet basis moisture content to keep that product under control from a dust perspective. But with the chemical formulation, you can reduce that by 4%. So in terms of when you're exporting iron ore, those numbers are significant in terms of how much water you need to apply to the product and also then ship around the world. Now, the other advantages of using the chemical formulation are that firstly, you achieve, if you do the right formulation, so-called dust-free handling. And that's from the mine site to the port, onto the bulk carrier, across to your end user. It should be designed to last long enough to get into the end user's backyard so they can then process it without causing dust problems in their plant. So that's the advantage with that. Whereas if you're just using water, of course, the product can dry out during that supply chain, and then you have dust problems further downstream. Of course, there are significant water savings to be achieved here, but it all comes down to the product type, how much savings you can obtain, and that's why we do need to do the testing. And of course, the other advantage is, particularly with iron ore, there's significant losses if you start shipping extra water around the world. So in terms of how do we apply this chemical formulation, well, we targeted a conveyor transfer through the process chain there on site. We also targeted the stacker that you can see here. So with drawings and photographs, you can see the existing water sprays there. They're not at the treatment nozzles that we used. This is the one I showed you earlier. So we just came up with a concept solution of a treatment chute with strategically placed nozzles, a certain type of nozzle that we can penetrate the product stream. But as I said, we needed 2 locations to get enough coverage of the particles in this product stream. And so here we see the end result and what a difference it makes. So if you can treat the product properly, you get to the particle level, then this is a sort of result that you can achieve. So a real contrast to what I showed you earlier with those huge dust clouds. So that's just a quick example of what you can do with these sorts of chemical solution formulations. So the rest of my talk, I'd like to talk about airborne dust suppression and the number of issues. If you start getting in this area, you have to think about what I suggest you think about is mist curtain efficiency. It's another form of dust control, so we have to think about control efficiency. So here we've got a very nice looking micro mist spray that's very good for airborne dust suppression. But in the application, in this case for an underground mine, will this thing work? Will it be efficient, and by how much? So to answer that question, you have to think about what's the size distribution of dust that you're dealing with and how much dust there is. Also, what's the droplet size distribution of the micro mist or the sprays that you're using? What's your nozzle design? What does it need to be? Is it water only? Is it air water? Are there impurities in your water? These are important questions and issues we have to deal with. And more from a scientific perspective, as I said before, these problems are physical science problems, and the solutions involve physics and science. That we have to think about the inertia and momentum of dust particles in the air, including any wind gusts or crosswinds that may be occurring. But also we need to think about the inertia and momentum of droplets, because we've got to get these things to interact between the dust and the droplets. And the most important aspect of airborne dust suppression is achieving a good dynamic balance of the droplets and particle air mixture. Other things, plant layout, dimensions need to be considered, as well as crosswind effects, obstruction, moving equipment, and so forth. So if you take all these things into consideration, you've got a good chance of being successful. But what I've seen around the place, and many examples where that hasn't been done. So you can see out in truck dumping operations like this, there's a lot of water being poured into the hopper. I haven't got time to show you the video of this, but all the dust just passes straight through, even though you're using lots of water and trying to control the airborne dust. And one way to sort of demonstrate, I suppose, the inefficiency of this type of what we call coarse droplet spray. If you see this video here, we took one of these coarse droplet sprays and put it under a high-speed camera. Here we're dropping some fine iron ore dust through the spray, and you can see it's passing straight through. So you can say, well, the efficiency of this is pretty poor. It's probably less than 10%. Whereas with the new sort of technology, the hardware I talked about earlier, like such as the micro mist spray, we are using, in this case, side-by-side comparison, the same amount of water, but the results are quite different, because here the droplets are matching the dust size, and the energy levels are there to entrain the dust successfully, and the efficiency of this is very high indeed. And so we actually have built a facility now at Wollongong in Australia where we can actually quantify the efficiency of such mist curtains. So one of the first projects we did actually was in China with our collaboration partners there. We're using rotary car dumpers, or tipplers we call them in Australia. And we have quite a number of these around the country at some of our fairly large installations, mainly for iron ore. This one is over in China is for coal. And so these are just basically your rotary car dumpers. Now there's quite a few of these that when they dump the product, of course, a lot of dust comes out. So we managed to get some good, nice volunteers. They can measure the air velocity for me and also do some dust monitoring. And so here we see below ground level the amount of dust being driven out of the hopper. And you can see it's quite significant. The other thing you could probably pick up out of this video is this water pipe. You can see just mounted on the top of the wall here. And this is fitted with lots of these coarse droplet nozzles. Now, whether the sprays are on or not, the dust still goes straight through them. So here's a case where that checklist wasn't gone through properly by the designers, and they just went for a cheap and nasty agricultural type solution, and they paid the price. There's no dust control. So anyway, quantifying the problem is the first step. The second step is to quantify the dust distribution of the things that we're trying to control. So we've got a median size of the dust of 35 microns. We can also evaluate the PM10 and 2.5s that we've got there. There's potential emissions. So we can quantify all that. And then we pick a nozzle that produces a droplet size distribution similar to the dust size distribution. So there's a good match between the two. And then we do some dynamic modeling just to confirm some of the numbers that we've achieved on site. We captured the maximum or peak air velocity coming out of this transient event. So with coupled, what we call coupled DEM, which is discrete element modeling, where we model the product dynamically, and we couple it with the airstream dynamically with computational fluid dynamics, or CFD. And then we capture, we quantify and model the whole dynamic problem, the physical science problem I talked about earlier. So with this information, we confirm that the maximum speed there is about of air coming out of the hopper is about 10 meters per second, which is quite significant. And this was confirmed on site with those measurements I showed you by video. So with this information now, we can optimize our final design and our operating conditions. So here's the system installed, the high energy micro mist curtain on the car dumper, and we're dropping product into the hopper, which is quite dusty. And the guys here you see in the video with the white jackets, they're the plant managers and the owners. They were quite intrigued because they could never normally stand here on this walkway when this operation was being done. It was just too much dust otherwise coming out of the pit or the hopper. And the management team actually said, look, this is all very interesting, but you must be using some sort of magic to achieve this. We've never seen anything like this before. And I said, no magic. And I said, no, you must turn off the nozzles. They instructed us we had to turn off the pumps, right, which we did. So then we did the next car dump, and we had to retreat and evacuate the building. We just couldn't even see the car dumper here. It's all hidden behind this big dust cloud. So the management were convinced, yes, the technology does work. And they actually put up a banner to celebrate the first successful dust suppression project in China at this unloading facility. You can see me there in the orange shirt. Man on my right, he's my partner in crime in China. He's my main collaborator who installs the systems, Renhu Pan from Fujian Longqing. The man on my left is the nozzle man. He has all the secret fancy nozzles that we used for this installation. His name's Vithold Ronda from Enviromist. The guy in the blue shirt is my right-hand man in Wollongong, Ian Frew, the lab manager. He assisted with commissioning, and all the other guys are the managers and owners, as I mentioned before. And we actually managed to get one smile out of these guys, and that's a major achievement in its own right. Just to show you that I'm not giving any fancy videos here or any magic videos, I'll show you from our latest car dumper project, side-by-side comparisons now of the product going into the hopper before and after the micro mist curtain. So here we see, obviously with no micro mist curtain, you'll see the dust coming out of here quite readily, causing all sorts of problems. And here you see some examples of nozzles again. It doesn't matter, they're coarse-dropping nozzles, whether they're on or not, makes no difference. And now with the micro mist curtain installed, same product, same operation, we just turned the spray bars on basically to show you before and after. And no dust. Nice bright day, no dust there to upset that. Okay, moving on. Applied this also to grab bucket ship unloading systems. This is for coal. The problem with these sorts of installations, they're very high up in the air, and the dust spreads far and wide. And if you look very closely, there's a couple of guys walking down here on the ground level. So measuring the problem here was virtually impossible. It was too dangerous to get over there and put probes in there. So we had to rely on modeling, which we did here. And again, we used the coupled DEM CFD approach to give us the energy level, so we knew what sort of energy we needed from the micro mist system, from the nozzles. And you can see the peak air velocities in the corners, and so we put some extra nozzles in there to counter that energy. So here we see the final solution. You can see the bigger nozzles there in the corner to deal with that. So it's the same product, same installation. Now we've got the spray curtains on. No dust coming out. It's totally contained inside the hopper. I'll run this video just to the end here, and if you see down the bottom of the video, you'll see the product line there. If you know anything about coal, you'll see that that product is still dry. So we're not wetting the product in any way. We actually, in some of these case studies, we've measured the moisture content of the product before and after. There's no change. So here we've got to remember we're targeting the airborne dust. We're not wetting the coal. If we wanted to wet the coal, we'd put in different nozzles. Okay, so crosswind effects, that's an issue that we came across many years ago. Of course, can upset a lot of otherwise good designs. And so we started building a test rig to model, quantify crosswind effects on, dust suppression sprays, as you can see here running. So we took a lot of data. We measured a lot of data, different nozzles, different pressures. And what we're looking here are these penetration curves. So on the y-axis, we've got axial penetration, and on the x-axis, we've got horizontal deflection. So just on the video, that's axial penetration. How far does that mist or jet spray reach with the crosswind here, and it's from right to left, and how far will it deflect in a horizontal direction? So we did a lot of experimental work, modeling all the different nozzles at different pressures, as you can see here. And we came up with a whole bunch of dynamic models which we can put into our simulation models, such as CFD. So here you see one such a nozzle being subjected to crosswind effects, and you can see the deflection there and how far that can potentially reach. And we've done full-scale experiments at different crosswind speeds, and we've got good agreement between the experiment and the modelled curves that we generated from this sort of calibration work that we did in the laboratory. So one of the first jobs we did here was in a conveyor transfer, and it was an interesting transfer where the product here was going along a conveyor belt, I think about 4 meters per second. It was coal, and there was a prevailing wind of about 5 meters per second in the opposite direction. And the product was coming out of the conveyor transfer, and it was quite dusty, and the existing coarse droplets couldn't handle it. So we used our models that I just showed you previously to design a solution. And this is the dynamic model that we produced, and you can see the deflection of those mist sprays here quite clearly, but we weren't sure how accurate that would be. So we had the opportunity, once the system was installed, as you can see here, and so the blue arrow there is indicating the direction of airflow, and you can see the deflection there, and it's driving the mist into the area, open area of that conveyor transfer where the dust would otherwise escape, and no dust was coming out. So by doing side-by-side comparisons, our predictions were spot on. And so we got the mist where it needed to be, even with crosswind effects. And if you know anything about flash photography, if there's any dust about, you'll notice you can't take photos. So here's a nice clean photo because there's no dust. So it's a good indication. The last thing I'd like to talk about, I hope I've got a bit of time to talk about loading of metal concentrates, lead and zinc, with the Rotobox technology. This is a system up in far north Queensland. You can see the Rotobox here going into the cargo hold, and they actually installed a mist curtain that you can see there. And it's a bit subjected to crosswind effects, so there was an issue with that. And there's also gaps that you see there. I might show the video because I don't know if people have come across Rotobox technology. The idea is to minimise your drop height, so particularly with metal concentrates, you don't want that stuff getting out of your cargo hold. So you can see the mist curtain coming on now. It's all fully automated. The idea is to minimise drop height, as I mentioned, so that you can see the container being rotated once you get about a couple of meters off the bottom there. And the problem with these sorts of dust emissions, if you have a dust problem, you won't see it because the levels are so low. You'll reach your exceedances and you don't even see it. If you do see the metal dust concentration, you know you've got a bit serious problem. Anyway, so that's the Rotobox, and we were asked, the question, what do we have to do to work out if that existing system is adequate, especially with crosswind effects? Now, we thought about measuring on site. For many reasons, we couldn't do that. So we relied on our dynamic modelling approach that I've just shown you previously. So we firstly use CFD analysis. To cut a long story short, this is a CFD domain that we produced with multiple refinement zones around the critical areas that we needed. So this is for the air modelling of crosswind. And from the Bureau of Meteorology, we found we needed to model 5.8 metres per second, which was a fairly consistent wind at this facility at 22 degrees to the ship's roll axis. From that modelling, we found there's actually a pressure differential. We actually created a slight negative pressure inside the cargo hold. And not much here, but it's a large area, don't forget. So it's enough to create that air movement to suck air into the hold, which creates turbulence, which can then potentially drive dust out of the hold. And from the output from our model, we can also quantify the average velocity of turbulence inside the cargo hold of 1.5 metres per second, which is enough again to carry dust out, but also a maximum of 5 metres per second down this back wall. So that can certainly create a lot of extra turbulence inside that cargo hold and dust emissions. So certainly these numbers show us immediately we need to have effective and efficient dust suppression. So we went to the coupled DEM CFD approach as we did previously on those other jobs. And this is just to identify your air velocities during that dumping operation and also air pressures. So we found that in the falling stream zone, we've got negative pressures, which is quite expected because that's air entrainment. But once at the impact zone, you get positive pressure, and that's what drives the air and dust out. But the question is, what about dust emissions? How can we predict or model that? So we use free settling velocity and the dust size distribution. And we focused on the PM10 potential emissions, and this equates to a free settling velocity of 0.012 metres per second. And with this information, we can actually predict dust clouds formed by the loading operation. And this is shown quite clearly, I think, in these two videos. These are dynamic models. The one on the left is predicting the air velocity from the coupled DEM CFD, and the one on the right is the corresponding PM10 dust cloud prediction. And you can see this is reaching, the PM10s are reaching high enough in the cargo hold to warrant concern about the effectiveness of the dust suppression system at the top of the cargo hold. So the worst case scenario, we modeled the whole range of things, the cargo empty, the cargo almost full, central loading, side loading. We found the worst case scenario was, of course, side loading, where the air and dust was driven up the wall. And that reached much higher distances, in excess of 10.5 metres measured from the bottom of the cargo hold. So that became our design case. And so all this work, then we could conclude that airborne dust is likely to be driven out by external crosswind effects. And so these gaps became a concern in the existing dust suppression mist curtain where dust can escape. And some recent dust monitoring was done by the port facility, and they have picked up some metal concentrates being lost out during the loading operation. So then what do we do about it? This is, I think, my final slide. So we need to implement non-intersecting swirl spray pattern arrangement by adjusting the nozzles and spray bars, as you can see here in a schematic in plan view. This is to minimize those gaps that you saw in the video. We still have some gaps in the corners there and also between the nozzles. So what we do then, we've done this on a number of jobs where we add deflector plates covering the gaps between the nozzles and the corners. And these are tucked away underneath there, so the rotor box won't impact on these deflector plates. So in plan view, we can see we're covering those gaps quite nicely. And in most installations, we don't need to do this, but in this case, with metal concentrates, we've got to take those extra steps to ensure that no dust escapes from the hold. And particularly in the corner here, we can cover those gaps as well. And the other thing too is, yeah, those spray bars were too high in that video. We've got to get them right down to the bottom of the coping there and install also higher energy atomizing nozzles to produce a finer water droplet to target that finer dust particle that we're dealing with. Now, this work is ongoing, and so hopefully maybe next time, if I'm invited back to this event, I can give you an update on how all this thing went how it was implemented and what the results were like. We'll definitely expect improvements on what they achieved on site. So for that, next time, I hope to see you there at this event, and I'd like to thank you for your attention. Sorry for going over.
Not at all, Peter. My apologies. I think I steered you slightly wrong there. I think I'd heard that there were some of the presentations were about approximately 20 minutes or so. So thank you. That's extraordinary. For me, I'll take away one of your first points, which is the bigger the dust problem, the bigger the solution required, and the bigger the cost for that, and the potentially the more horrendous waste of water that flows with it. But the idea that you can actually get to dust extinction, which is a phrase I've never heard before, that if you're using intelligent management, you can target the dust, not the product itself. So that was fascinating content there. Could I ask what sort of
Thanks for the comment, Richard.
Oh, no, you're very welcome. It's if an organisation is interested in following up on this, where are we in this technology? Is it really leading edge at the moment now, and so therefore there aren't sort of big commercial opportunities or solutions out there? Is it a case by case?
Well, I suppose the message here is that we do have the technical solutions for these big problems, and it does not involve a bigger baghouse or adding a lot more water cannons to your problem, or water in general. So there are more elegant solutions. If I had more time, I could show you case studies where we reduced water consumption by 70% at big truck dumping operations, you know, where lots of water, 1,000 litres per minute were used. It had no effect on the dust, and we came in with 300 litres of water and we stopped the dust. So it's using, you know, being smarter about what the problem is and what the solution needs to be. I mean, in the end, we can't do everything, but we have targeted some very big stockpile installations and dumping and ship loading operations, as I mentioned before. So we do have the solutions there. The next thing we're looking at are some of those really big tipplers up at Port Hedland, where they're using massive baghouses at the moment, trying to suck that dust into a baghouse, which is probably the most inefficient way of controlling dust. Now, we've done the numbers, and we could save them megabucks by putting in more efficient hydraulic sort of dust suppression systems. We can do away with the baghouse. We can do away with stack emissions. We can contain the problem completely in the hold or in the hopper. So that's the difference we can achieve here with these new technologies. It all has to be modeled properly. We have to optimize it, and then you've got the best chance of success.
Requires that very careful analysis up front, so that you're then targeting as effectively. The system can only be as good as the knowledge and research that's gone into the front end.
That's right. But the whole idea is to come up with a full-scale solution on your computer before you commit to any installation or final design costs.
And is it now a case of you just need to let the world know about this, and for people to...
Well, the world in Australia knows about it. All the mining majors have embraced this. It took us probably 10 years to convince them to think in a more modern approach. A lot of mining companies are guilty of that. It takes a long time because they don't like changing anything, because they just want to ship out more and more product. But in the end, now they're embracing this, and now it's becoming a standard. This dynamic modelling approach is being written to a lot of standards. So that's currently in Australia, but these are international companies, so it is spreading. Excellent.
And you think, what, in another 10 years' time, nobody will be blasting dust with inefficient, coarse dust suppression systems?
Well, look, I'm sure they will still be there, Richard. just keeps me busy.
Excellent. Could I check to see if there are any other questions in the chat? Has anybody got any questions for Peter? This stage? I'm not seeing anything, but I think Ian or Simon will let me know if anything comes up, and we've also got the opportunity for Q&A at the end. And apologies again, Peter, for if I had you galloping through that rather than cantering on time.
I'm sorry for the bit of a rushed approach there. I just want to try and at least get my 30 minutes in.
Well, absolutely welcome to, and you know, this is an area that if I hadn't been at this event, I wouldn't have known anything about. So it's this is exciting stuff.
Okay, oh, it's good. I'm glad you found it interesting.
Thank you. So I believe now we are about to hit a commercial break. I make it 20 past 2 British summertime in the afternoon. So I think there is around about a 15-minute commercial break. So if we're looking at returning at 2:35 British summertime to the final presentation, but now I'd like to hand over to the commercial break.
In 1922, Professor Heinrich Armund laid the foundation stone for the establishment of Armund, today a globally operating group of companies with innovative and customer-oriented solutions for the conveying and storage of demanding bulk materials. In conjunction with the headquarters of the product companies Armund Fördertechnik in Germany, Schade Lagertechnik in Germany, and Samson Materials Handling in England, the global conveying and storage technology business is spearheaded by locations in Europe, North and South America, Russia, India, China, Hong Kong, and the United Arab Emirates. Equipment for the conveying and storing made by the Armund Group of companies is used worldwide in the cement industry, the metallurgical industry, in power plants, ports and terminals, in mineral processing and mining, and in many other fields in which large volumes of bulk materials need to be continuously conveyed. Port installations, whether next to the sea or along a river, require the loading and unloading of bulk materials to be exported or imported. This is a domain for Samson mobile loading and unloading equipment. The Samson mobile ship loader allows vessels to be loaded at a rate of 2,000 tons per hour. In ports with only restricted space, the mobile loader may be moved away and stored between loading cycles. For the unloading of vessels, the Samson Ecological Hopper, or Eco Hopper, with its dust suppression system for environmentally friendly operations, fits into any installation, even those with a narrow jetty. Further areas with applications for Schade, Samson and Armund equipment are the handling and storing of any kind of minerals like phosphate, ore or potash. Handling alternative fuels and biomass, which are increasingly used in many industries to ensure sustainability, are also applications for Armund equipment. For all these industries and related logistics to and from the ports and terminals, the companies of the Armund Group design and manufacture innovative equipment to suit the individual requirements of the various processes.
Buttimer Engineering is a family-owned company founded in 1978 to serve the Irish agricultural industry. While building a strong expertise in bulk materials handling, it has grown into an international engineering firm, with project teams located in Ireland and Poland, serving an increasingly international range of clients. Buttimer Engineering is a diversified mechanical engineering company which specializes in advanced bulk materials handling systems. Batimer delivers mechanical handling processes and projects for bulk port terminals, as well as agricultural and industrial facilities. The company's capabilities range from the supply of bulk handling equipment right up to full turnkey projects, including conceptual design, detailed drawing, procurement, installation, and project management. Batimer can design solutions for ship loading and unloading, conveying, storage, product drying, and processing of a wide range of dry bulk commodities. Systems include pneumatic and mechanical conveying, storage silos, aspiration systems, and bulk outloading to trucks, rail wagons, and ships. Experts in handling dry bulk products, Batimer frequently works with clients to deliver facilities where dust control, ATEX systems, and high-quality safety features are in place. These features include aspirated outloading stations, designed with environmental control features, minimizing dust and emissions during the handling process, integrating bulk handling facilities efficiently and cleanly with wider logistics networks. The company prides itself on delivering solutions that fully meet the customer's requirements, and the company's success is due to reliable project delivery and ongoing client satisfaction. In 2014, Batimer Engineering launched Dock Solid, a bulk port equipment brand. The Dock Solid range of environmental and standard ship unloading hoppers has been developed by Batimer over more than 2 decades. Dock Solid hoppers can be mobile, rail-mounted, or installed as part of a terminal building. Loaded with a crane grab, each hopper is custom designed to meet the need of the port, bulk product, and client. The mobile environmental hopper is an extremely robust and flexible unloading solution with state-of-the-art dust control features. Dock Solid hoppers are engineered in Ireland and fabricated in-house by Batimer Engineering. They can be shipped to bulk handling terminals around the world.
Thank you. Thank you for just to get my list back up here. Thank you to all of the organisations presenting their material during the commercial break, to Badeshi, to Bruck Sewertel, to Buttimer Engineering, IGUS, and the Ammon Group, particularly the Samson brand. So welcome back to the Association of Bulk Terminal Operators, Bulk Terminals Riga online conference, kindly hosted by the Freeport of Riga Authority. Our final speaker today is Professor Mike Bradley, and as he was introduced at the head of the session today, I won't revisit some of the content about the Wolfson Centre, but I will just give you a little bit of backstory. His apprenticeship was with BAE Systems, where he took his first degree at Thames Polytechnic. And after a while working in flight automation research at BAE, he returned to Thames Poly to do his PhD. And after his PhD, he, quote, failed to reach escape velocity from the Wolfson Centre, becoming first a consultant, then manager, and finally director in 2000. Mike also serves as chairman of the Solids Handling and Processing Association, which is the premier UK trade association for suppliers of solids handling equipment. I think if we're not expecting Mike to deliver his presentation live, but he will be online to take questions. And I'll hand over now for the presentation. Thank you.
Good afternoon, everybody. So you're listening to a recording here because I've had some trouble with WebEx, I'm afraid, but hopefully this will enable you to hear me loud and clear. So this afternoon I'm talking about explosions and fire in bulk ports, a subject we have talked about before in ABTO, but one that continues to be a problem at bulk terminals. I'm going to talk briefly, first of all, about ammonium nitrate hazard and safety, and then I'm going to talk about dust explosions, which are a much more common phenomenon, as well as fires, preparedness, where to get information on safety, regulation and responsibilities. I'm sure you were all as horrified as I was to see in the news on the 4th of August this year, the huge explosion in Beirut, the 6th largest non-nuclear explosion in history. This was a blast heard 150 miles away. 218 were dead, 7,000 injured, and $15 billion worth of damage. It was a big event. You see where in the middle of this slide there's a lake there, what looks like an inlet. That was originally dry land. That is where the cargo shed was that was holding a cargo of 2,750 tons of ammonium nitrate fertilizer, of which we think about 600 tons exploded. And on the left-hand side, you can see the grain silos, which were the main food intake store for the country of Lebanon. A little bit about the story behind this. The MV Rosus here was a ship that was carrying this cargo en route to Mozambique, and they didn't have enough money to pass through the Suez Canal, so they ported at Beirut to pick up some extra cargo. When they loaded this cargo on top of the deck hatches, unfortunately they damaged the hatches and the ship was declared unseaworthy and not allowed to sail. The owner, unfortunately, went bankrupt, so there was nobody then to take responsibility for this. And the poor crew were locked on board the ship, basically stuck there for about a year. And this happened a number of years ago, and in 2013, in fact. And about 6 months afterwards, a judge ordered the cargo to be seized and brought ashore in part payment for the outstanding port fees. The ship was then abandoned in the port, and eventually it sank in 2018, and the cargo remained there for 6 years. The Customs and the Port Authority were well aware of this, but there was a problem, which I'll talk a bit more about later, which meant they couldn't move it. Just a little bit about ammonium nitrate. Ammonium nitrate is not an explosive, it's not fuel, it's not even combustible, in fact. What it is, it's mainly used as a nitrogen fertilizer. And if you look at the molecular structure over here on the right-hand side, you'll see it's made of two radicals. You've got the ammonium radical and the nitrate radical, bonded together chemically when it's made, but that bond is not very strong or stable. I liken the relationship of the two radicals in ammonium nitrate. It's like two people who got married just because they were left on the shelf and there was nobody else to have them. And the smallest shock, and they will part from each other. And when they part from each other, you get an oxidation reaction. It's used as an oxidizer very often with oil in what they call ANFO, ammonium nitrate and fuel oil explosive, which in fact is the most commonly used industrial explosive for mining, quarrying and tunneling and so on. However, if you heat ammonium nitrate, it will decompose and these radicals separate from one another. The decomposition itself generates more heat. So, of course, you can generate, if you've got enough of this stuff, a runaway reaction, which accelerates. And especially if there's some kind of a shock, it can initiate that decomposition very effectively. And there have been many, many disasters with AN. In the last 100 years, 35 major disasters, lots of smaller ones as well. A couple there in the early years that you see in Germany and Belgium where AN was caked in a silo and they used explosives to loosen it. That may seem crazy, but in point of fact, this was very common practice in those days and did not usually cause a problem. But if you get it wrong, it can. In recent years, it's mostly been caused by, these accidents have mostly been caused by fires. So the 1947 Texas City explosion on the USS Grand Camp, a cargo ship which caught fire, 2,300 tons of AN went off, killing 581 people. And this death toll continues to this day. 2013, you see there in West in Texas, a fertilizer factory, 15 people died. Tianjin in China, again a fire, nitrocellulose was stored next to AN and caused the death of 173 people. And then the event in Beirut last year. Yeah. So what happened? This cargo was there for 6 years. The Port Authority, the Customs were aware of the danger. They kept writing to the judiciary to say, can we please move this cargo? Can we give it away, sell it away, dump it in the sea? Can we do anything? We're not happy with it here. But unfortunately, the judiciary didn't respond. I guess they thought they had more important things to do than think about a small cargo of a few thousand tons of material in the port. So in 2020, somebody thought it was a good idea to store a cargo of fireworks next to this 3,000 tons of bagged ammonium nitrate. Now, who would have thought of putting fireworks next to AN? A little bit later on, somebody thought it would be a good job to do a welding repair on a door adjacent. Now, doing a welding repair on a door adjacent to some fireworks, that doesn't sound like a great idea, does it? So there was clearly a lapse in understanding of risks here. The welding, of course, set light to the fireworks burnt, heating the AN, the fireworks exploded, that generated a shock, which then initiated the decomposition reaction. And if you look at the largest explosions in history, other than nuclear explosions, these are the 10 largest explosions in history. 5 of these were caused by munitions on board ships and in other stores. 1 was caused by rocket propellant, but 4 of them have been caused by ammonium nitrate. 40% of the largest explosions in history caused by AN. Just think about what that means about the danger of this material. If you think about what AN can do, it is no exaggeration to say that a cargo of ammonium nitrate is the next thing to a nuclear bomb. In some ways, it's more dangerous because, unlike a nuke, it can be set off accidentally with fire. That won't happen with a nuke. Now, to be fair, large quantities of AN are handled all around the world, and detonations don't occur that often. The likelihood is quite remote. The problem is the consequences are so large. Safety principles, though, are not too difficult. And if you look at this, the way to keep AN safe is avoid exposing it to heat. But while the principle is simple, if you think about it in terms of calculating hazard levels, we calculate hazard levels by multiplying the risk of an occurrence by the consequence of that occurrence. And because the consequence is so terrible if you have an AN accident, that means to keep the hazard acceptable, you have to keep the risk to very low levels indeed. We have to be extremely diligent. Let's just think about identifying our risk materials here. It is quite rare for pure ammonium nitrate to be handled in bulk. It does happen, but it doesn't happen often. Most AN is bagged. So you might say, well, why are we bothered about that in a presentation about bulk terminals? Well, the fact is, many bulk terminals are also adjacent to other cargo handling operations, and many of those handle bagged materials such as AN. So if you have anybody handling AN even adjacent to your bulk terminal, you need to think about the safety of that, because if there's an accident, it will affect you severely. However, there are fertilizer blends that are handled in bulk very commonly, and if you have more than 28% nitrogen in your fertilizer blend, that is when you are at risk. So that's something that you need to check with the fertilizer blends that you may handle in bulk. So keeping it safe also means avoiding contamination. With the blasting mixture of ammonium nitrate and fuel oil, we only have 6% oil. So even a couple of percent of organic combustibles can make it unstable. Things like dust from feed, dust from wood pellets, these sort of things, cross-contamination. Make sure handling equipment is thoroughly cleaned before and after. And likewise with stores. And protect the piles from dust settlement as well. Obviously, the key thing with AN is to prevent any possibility of a fire anywhere near it. And it's not good enough to look at controlling ignition hazards in materials stored close to AN. You must keep combustible material away from AN. So anywhere where you're storing AN, you must never store wood or fuel or oil or anything that can burn anywhere in the same building. Because even though the likelihood of it catching light may be small, if you do have a fire next to AN, the consequences can be so terrible. Likewise, your store obviously needs to be incombustible, made of masonry or steel, certainly not of wood or plastic. Another thing is to make sure any drains nearby are blocked or filled, because if AN melts in a fire and runs into a drain, that contains it, and the confinement increases the risk of detonation very greatly. And obviously smoking and hot work. Mobile plant, inevitably you're going to be using mobile plant when you're handling this, and mobile plant is a common source of fires. We've seen many mobile plant fires over the years. You must make sure that your mobile plant is not leaking oil, it's free of grease or organic dust or anything like that, and preferably with a self-extinguishing system. And clearly do not leave mobile plant running unattended anywhere near AN. I'll talk a little bit more about fire risk with mobile plant later on. So handling AN safely also means maintaining quality in storage. Avoid exposure to dampness, because if AN gets damp, it cakes. And when it cakes, it's much more susceptible to detonation, because when the particles are bonded to each other in a hard structure, clearly a detonation wave can pass more readily between the particles. So caked AN is much more dangerous than fresh AN. So make sure your stock is properly rotated. You don't keep stuff there for a long period of time at the back, not moving. Keep it turning round and get it out as quickly as you can. And obviously, if you do have a fire anywhere near AN, you must tackle that fire at an early stage before it starts generating significant heat. But be careful, because any heating of the AM liberates nitrous oxide and nitric oxide, which are highly toxic. Water is very good for firefighting because it's very good for cooling. A simple thing, don't expose it to heat. Obviously, trying to make the risk of exposing it to heat so very small to keep us safe is something that needs great diligence in making sure that those rules that I've just talked about are followed. Plenty of information. Most states have their own regulations about handling AN, but the UK Health and Safety Executive published a little self-help checklist there, which I would thoroughly recommend. Even if you're not in the UK, just download that and go through it, because you'll find it very useful. So enough about AN. Let's move on and talk about dust explosions in bulk terminals, a much more common occurrence. Not as catastrophic, not as large an event as an AN event, but nevertheless still cost probably a good deal more money actually all around the world. And this doesn't only happen in failed states and remote places. This is a common enough occurrence in many states where there are good regulatory frameworks and so on. This was Tilbury Grain Terminal in the UK, August last year. The tops were blown off all of the silos there in the grain terminal due to a dust explosion. And the thing that I never liked about Tilbury Grain Terminal, because I spent a lot of time at Tilbury Grain Terminal over the years. Look where the offices and the control room are, right in the middle of the silo block. Now, if this explosion had been much worse, it could have wiped out everybody that could have done anything about controlling the incident. So there's a lesson there. Don't put your control rooms and offices in the middle of silo complexes. Fortunately, it wasn't as bad as it might have been. But it did take 3 weeks to contain all the fires subsequently. And of course, a massive cost to rebuilding. The concrete silos were too badly damaged. They were cracked because of the explosions. And so a lot of money has had to be invested to demolish the concrete silos and rebuild a whole load of new silos there. Now, we have a very good system for preventing dust explosions and fires, and if it's used properly, it works very well. And this is in Europe or the UK, it's what we call the ATEX system. If you're outside of Europe, quite a lot of people outside of Europe use ATEX because it is a pretty good system, but there's the alternative international IECEX system, and they're broadly the same. And the way in which these regulatory systems work is you look at the plant and you identify zones according to the risk level of having explosive dust. And then you choose equipment that's rated for use in those zones. And the way in which this works, if you look over on the left-hand side, these are our risk levels. So we identify our zones. If we have a zone where we have explosive dust concentrated in the air frequently, and in normal operation, so that's typically inside filter houses and such like. That's called a high risk area, which we call zone 20. And in that zone, you have to use equipment with what's called a 1D rating. That's a very high level of prevention of generating an ignition source. If you have an area where you may get explosive dust in normal operation, but not very often, then we call that a medium risk or zone 2-1, and you can still use zone category 1D equipment. You can also use category 2D equipment, which has still significant protection against generating an ignition source, but not as high as category 1D. And then if you have areas, and there are a lot of areas like this on a plant where you don't normally have a high concentration of dust in the air, but if there was a malfunction or if there was misuse, then it could possibly be foreseen. And we call that a low risk or zone 2-2 area, where you can use 1D or 2D rated equipment, but you can also use category 3D equipment. And a lot of category 3D equipment is actually only standard equipment, but that has been subjected to an ignition hazard assessment to make sure that it doesn't give an excessive risk of generating an ignition source. And then don't forget the rest of the plant, the unzoned areas, where you can use any equipment that you like, and you can do hot work as well if you want. It's a simple system. The only real challenge here is defining the zone. That's where there is obviously judgment required. But provided this is followed properly, then there shouldn't be a problem. However, the problems still continue to exist. So in terms of the equipment category, I talked about category 1, 2 or 3, category 1 for use in high risk zones. What the standard says is that even during a rare and unusual malfunction, it will not generate heat, basically. And the ignition hazard assessment has to be made by a notified body. And as we go down the categories, so the level of protection and the requirement is lower. Mobile plant, if you are using it in areas with combustible cargoes, like feed, or wood pellets or anything like that where you have dust that is combustible, that should also be ATEX or IECEx rated. It is not good enough to use standard mobile plant that doesn't have an ATEX or IECEx rating. And we've seen so many fires started in mobile plant. So investigation of a number of incidents that I've personally been involved with, or with my good friend John Petherlis of Southdown Solutions, who has furnished quite a lot of information for this presentation, has also been involved in forensic engineering, as it were, a number of serious incidents over the last few years. What were the causes of these? All of these were on biomass plants, either generally wood chips or wood pellets, and many of these led to substantial losses. And one of the challenges is that people don't always read the standards properly. And for example, one of the common causes of ignition is where you get dust trapped in an area where there is moving equipment. For example, between the shaft and bearing housing, if you get dust packed in there, it rubs, it can get hot, and then that can start to smolder and can initiate a fire or an explosion. However, something that is often overlooked is malfunctions of equipment that can cause some friction inside the equipment, even at slow speed. Now, there is generally a view that if you have surfaces touching at less than 1 meter per second, they cannot initiate an explosion because you can't generate sparks, basically. However, even slow running equipment, if you get friction, can cause enough heat to initiate a fire. So this is a scenario we've seen on a number of occasions where we have dust on the surface of some equipment. We have equipment items that don't normally touch each other, such as a shaft in a bearing. And where that shaft has moved and started to rub, it's then generated heat, which has then caused the dust to smolder. And then when the dust fell, it initiated a larger fire or an explosion. That scenario is not specifically mentioned in the standard. Here's an example. This was a screw feeder at a power station handling wood pellets. And here's the shaft. The shaft was retained by a taper lock bush. So it didn't have a very good positive endwise retention. And under the end load, the screw shaft moved and it rubbed against the end casing. And you can see here where it has caused then the dust on the end casing to smoulder. And that smouldering, you can see here's the where it come up against there, because the mating place, as it were. That smouldering material then initiated a fire. Now, if you read the standard, as I said, it says that less than 1 metre per second, there's no danger of an explosion. But often people read down that far and they don't get any further when making their ignition hazard assessment. Because it does actually say that further down that if you have dust in contact with a hot surface, that can ignite and can give an ignition source for an explosion. And further down again, it says even slow moving parts can cause a large rise in temperature. So if you read this carefully, you can infer that you do need to look out for that kind of failure that I've just described to you. But unfortunately, people don't always do so. Now, there is a particular problem with wood pellet dust, and I'm drawing this to your attention because it is now such a commonly handled cargo. Wood pellet dust has a higher level of susceptibility to these problems than many other materials. So if you're handling wood pellets, you have to be especially careful. Here's an example of, this didn't end in an explosion, but it did end in quite a big fire. And this was a wood pellet manufacturing facility where the fire was initiated by a conveyor belt mistracking. So the conveyor belt ran off to one side and it rubbed on the casing. The rubbing on the casing generated heat, and that initiated a fire, which then the burning material dropped into the silo. There was a large fire there that caused a lot of damage. It spread through the plant very quickly. Why was that not detected? For this equipment to be suitably ATEX rated for use in this zone, it was fitted with belt tracking sensors. Because the belt tracking sensors are your prevention of frictional heating. And the belt tracking sensor is a protective device, shall we say. But for some reason it failed. And the reason that it failed was because when we walked around that plant, sorry, I've just moved on a bit fast. When we walked around that plant after the incident, we found a lot of sensors like that, heat sensors on bearings, belt tracking sensors and so on. They'd been installed but never connected. So the sensors were there and the wires were just hanging, never been hooked up. And for half a year since commissioning, people have walked past those and never asked, why are these sensors not connected? Now, can you believe that? So where you've got sensors, you've got to make sure they're properly connected. However, just moving on, housekeeping. All of those incidents that I've just talked about, they did not result in major explosions. And the reason was because of housekeeping. The facilities have been kept clean. There was not dust on the floor. And if you look at dust on the floor, this is the biggest hazard that turns a small event into a catastrophe. If you have a small ignition here and a little bit of a blast, it may cause a little bit of localized damage. But if there's dust on the floor, the dust on the floor comes up, that gets ignited, it generates a fireball that travels through the whole area. That's called a secondary explosion. And thanks to my friend Dave Price that gets onto the diagram there. How much dust on the floor is a problem? If you have 1 millimeter of dust on the floor and you bring it up into the air, that's enough to cause an explosion. So the place must be kept clean. 1 millimeter of dust is enough to cause a devastating secondary explosion. This is an example here from a sugar mill. This was Imperial Sugars in Georgia in the USA. They had a small explosion in a conveyor, and it would not have been a problem, except that when this got out into the workplace, there was sugar dust on the floor everywhere. It was known as a dirty place to work. They wouldn't spend any money on cleaning. The result was 13 people were killed. And had there not been dust on the floor, nobody would have been hurt. So keeping the place clean is incredibly important. This was another incident, Bosley Mill in the UK. This was where they were milling wood flour, so very much the same sort of dust you get from wood pellets. And again, they had a small incident, but because of the poor housekeeping, a fireball went through the whole facility, killed 4 people. One poor guy, they never even found any remains of him. He was basically shredded in the explosion. That's no way to go. We don't want to go to work to be faced with that sort of risk, do we? So keeping the place clean is incredibly important. This is the cost of dust on the floor. If I take an example of Drax Power Station, a facility with which I'm intimately familiar, having done a lot of work on handling of biomass material there, they pay 30 people to work on shifts just cleaning up dust, and they collect 10 tons of dust every day. But even though they've had a number of minor incidents, they have not had a major explosion, they have not had an injury, and that's because the place is kept clean. So cleaning costs money, and it doesn't sound as though it's very productive, but the cost of not cleaning can be catastrophic. It's one of these things where you think, if you think safety is expensive, you should try having an accident. For further reading on ATEX and IECEx, download this guide from Sharper. This was something that we worked on. You can go to the Sharper website, free to download, and that will give you a guidance to your responsibilities. Obviously, it's necessary to prepare for when things go wrong, because they will go wrong. If you are handling material that's combustible and there's dust in it, sooner or later you will get fires and or explosions, and you need to make sure that you're ready for that. Don't rely on the fire brigade. The fire brigade, by and large, will come in and do things wrongly and make matters worse. So you must have your own methods, your own procedures for fire management. And of course, fires actually are a lot more common than explosions, and they cost therefore a lot more money, even though they don't have the same dramatic effect. You may, if you're unlucky, you might see one dust explosion in your lifetime, but you'll see quite a few fires working in this area. So obviously, there's not as much money in selling preventive measures either for fires as there is for explosions, because everybody knows how devastating an explosion can be. So there isn't as much focus, but you need to put that focus on. So firefighting in silos, if you get a silo fire, how to deal with it. Don't deal with it like this. Don't rip it open, let the air in. That's the worst possible thing you can do. And if you have a silo fire, don't open the hatch on the top, because you'll be faced with a backdraft explosion like this. I'll show you in a minute a source of information on how to deal with these, by the way. The cost of these sort of catastrophes. This was a fire at Tilbury Power Station in 2012. This was initiated by a light that overheated with dust on top of it. They lost $15 million to do repairs, which was paid for by insurance, but they lost $45 million in lost revenue, and of course that wasn't insured. So just because you're insured doesn't mean you're safe. So lessons for design, ignition hazard assessments I've talked to you about, a HAZOP type approach on those. Do not rely on notified bodies to do the risk assessments properly. Check any equipment you're bringing into site, get your own engineers to check the risk assessments. And if they don't know, get them to learn how, because at the end of the day, you need to take responsibility yourselves for these things. Make sure that things are assembled properly, especially on commissioning. I mentioned the safety systems on that pellet facility not being connected. Make sure they're connected, make sure they're tested, make sure there's proper certification for handover as well. And in utilization, check the cargoes you're handling. Some cargoes have a lot more dust, they're drier, that dust is more susceptible. So just check that you're not getting cargo that has a higher level of susceptibility to fire or explosion. But the biggest thing, as I said, is housekeeping. Keep dust off the floor. Dust on the floor is what kills people. and have the plans for when things go wrong. And we need to get people more educated in this. People working on the ground need to be able to spot problems and raise those difficulties without being thought of as being troublemakers. So further sources of information. In 2019 ABCO conference, we published a presentation there, Biomass Fire and Explosion Incidents, Lessons Learned and Recommendations. You can get that from Simon at ABCO, or you can get it from me at the Wolfson Centre. And this goes into a lot more detail about things you need to do to protect yourself. As a general guide to ATEX and responsibilities, as I said, download the Sharper guide there. But also coming up fairly shortly, ABCO and the Wolfson Centre are getting together to run a short course on handling imports and terminals, and that will have a certain amount in it about fire and explosion. So again, contact Simon on that, or alternatively go to the Wolfson website. And it just remains for me to say, keep safe, stay safe, keep dust off the floor, and thank you for your attention.
Thank you, Mike, and for your pre-recorded session, but you are now live.
I am indeed. I'm here if anybody's got any questions.
Any questions? I mean, I personally, I learned a lot from that session, and I thought I'd kind of been through the. Oh, I think we might have lost Mike, but I'm not sure that. I think I might have been round the circuit a few times on dust and ammonium nitrate, but I still felt that I learned some brand new material, like the fact that the Beirut incident was the 6th largest non-nuclear explosion known to history. And looking at dust explosions themselves, how 1 millimeter of dust is enough to cause a devastating secondary explosion. And somewhere like Drax Power Station in the UK collects 10 tons of dust per day with 30 people on a permanent cleaning operation. So I think I saw a question pop up there in the chat, which I'll just try and find it. I'm just checking that is Mike still with us? I had a message saying he dropped out. Could Ian or Simon confirm?
I'm afraid it does appear that we've lost Mike again.
Okay. Right. So what we'll do is take any questions. If you'd like to put any questions into the chat, we'll pick those up and make sure that they are sent back out to, or the answers are sent back out to delegates when Mike's had a chance to have a look at them. And oh no, I've got a Mike has joined the meeting again message. So I'll just give it a moment to see whether he can come online.
Yes, sorry about that. Somebody literally just rang my phone as I came on, and that dumped me out of the meeting. What's the chances of that? So yes, if anybody's got any questions, I can take them now if they like, if there's time, Richard.
Okay, so I've got a question that I'm going to read through from Peter Whippich. Mike, can things change when handling ammonium nitrate dust as opposed to prill, say at the end of dilute phase pneumatic conveying system, at the end of a dilute phase pneumatic conveying system?
Yeah, that's a very good question, because obviously the key thing about ammonium nitrate is that it's not a dust explosion hazard, because it isn't a fuel. So therefore, you're not going to set it off in small quantities and get a dust explosion with it. The real big hazard is where you have the concentrated quantities. In many ways, it's kind of the opposite of a fuel, because with a fuel, the big danger is where you've got the dust in the air. But with the ammonium nitrate, you know, the issue is basically because you've got where you've got a concentrated quantity of it, you can get this detonation effect. So I think it's something, obviously, you don't want to provide excessive heat to it, because I guess in theory you could get decomposition in the dust cloud, but I think the amount of energy released is relatively small compared with a fuel.
Excellent, thank you. You showed that historic set of examples of incidents. What is it? Awareness of these risks, or is it something else you think that is leading to you know, repetition of dust and or ammonium nitrate explosions?
I think it's a variety of things. As always, there's not any one single cause. I think as far as AN is concerned, you know, I've never investigated an AN incident myself, so I'm going on what I've read and what I've researched on this. But my impression is it's mostly a lack of awareness of the risk. And you know, for most cargoes, we store cargoes next to things that can possibly catch fire, but generally don't catch fire. You know, fuels in piles of grain and feed, and things that are packed in cardboard boxes and that sort of thing. And most of the time, these things don't catch fire, but just on the odd occasion that they can, if you then get that fire and it can then cause heating of the AN, then that's the issue. I think people don't realise just how significant the risk is, and it's this business of hazard being the product of the risk of occurrence and the consequences of the occurrence. And it's simply because the consequences are so high that the risk of exposure to heat has to be kept incredibly low. As I said, when you look at the number of ports that handle AN, and you know, almost every port handles AN in significant quantities, and you know, the number of incidents, you get one of these incidents probably every sort of 5 or 6 years on average. It's really that kind of illustrates how you have to be a lot more diligent about controlling the risk than you do with the risk factors for dust explosions. With dust explosions are still incredibly common in spite of the ATEX system and IECEx systems, which, if they're followed, work extremely well. And there are a number of things. One thing is, you saw with the fire at the Balcas facility, that occurred, that was would not have happened if the active safety systems had been connected. And you know, I find it astounding that you can have safety systems that are essential to compliance to the ATEX code, and then there is no check or certification on those at handover on commissioning. I just find that absolutely astounding. But you know, this is an example of what we see, unfortunately. And I think also in the workplace, a lot of people who actually work in the workplace, they're not as aware as they ought to be of the danger of dust on the floor. The number of ports that I go round where they're handling feed and fuels and that sort of thing, and there's significant quantities of dust on the floor, which, if there was to be a minor event, would then be potentially a catastrophe. And I think if people were more aware of it, they would report issues of dust emission. You know, Peter talked a lot about dust emission and how to control dust emission. I mean, obviously we have to be careful in using water with biomass materials, but you know, that's another factor. The point is that dust is not just a nuisance; it's a killer when it's combustible. So I think a lack of awareness of that, and I think also there is a significant lack of awareness of people at a maintenance level as well. Because when equipment is replaced, when it's repaired and so on, the condition of it and the equipment that's used to repair it and the way it's assembled needs to be done in such a way that the ATEX rating is retained. And quite often this is not the case. If you go to the oil and gas industry, there is a very thorough mandatory training for people working in ATEX zoned oil and gas facilities that maintenance people basically have to go through to understand what it is that they need to do, understand the principle of zoning, how to identify zones, how to make sure that when you change equipment, it's suitable for the zone and that sort of thing. But sadly, in the industries that handle dusty, combustible solids, we don't have that. And I think this is an area, and you know yourself, Richard, training is what keeps people safe as much as anything. You can have all the regulation in the world, but if people don't know about it, if they don't comply with it, they won't be safe. And I think this is something that we really just need to keep banging on about education. The number of times I go to a facility and I see things that I think are a bit questionable, and I say, "What do you do about ATEX?" and the response is, "What's that?"
So it does strike me that there is a risk that as you say, when it's something like ATEX, where you maybe expect to be regulated to a greater extent, that there's a risk that the organisation doesn't see its duties and responsibilities of the duty holder, because I can't imagine running a plant or facility where if I knew it had to be ATEX, to meet certain regulatory frameworks or standards, that you wouldn't check that, the installation on handover or on return after it had been taken out for repair or have you. But clearly that does still seemingly happen sometimes.
Yeah, it does happen, and several of those incidents also that I reported there, they were caused by ATEX rated equipment where the ignition hazard assessment had been done by a notified body. So this was category 1 equipment, which has the highest level of protection on it. And even though the notified body had done the assessment, they clearly had not done their job properly. I fear the problem is notified bodies, there is nobody to police them. They're given a government license, and it's more or less a license to print money, to be honest with what they charge. But unfortunately, there's nobody to actually question whether they're doing their jobs properly. And I fear this will continue to be the case unless we get on top of the real expertise level amongst the people in the notified bodies. So, my advice to everybody is, if you're buying ATEX rated equipment, even if it's been notified body checked for the IHA, look at it yourself.
I think I saw another question come up in the chat. Just bear with me. So from Peter Whippich, Mike, how common is hazardous area classification in the UK, and how many people can do this very specialised type of work in the UK?
Because in the UK we've been using ATEX now for how long? Nearly a quarter of a century, I suppose. Certainly over 20 years. This is very commonplace. Anybody who's working in this area in the UK, generally speaking, certainly should have knowledge of it. And I would say 95%, well, probably 90% of companies do this pretty well. So there are quite a lot of people who are actually doing that, and but because of the number of people involved in it, that's enabled us to tease out quite a lot of knowledge about good practice.
Excellent, thank you. A response there from Peter.
Thank you, Peter.
So I don't see any other questions at the moment. Could I throw open, just in case there are any questions from any of the delegates for any of our speakers today? Nothing showing up just at the moment. No. Okay, well, in that case, I would like to thank once again all of the speakers today. It's been an extraordinary amount of learning that I've achieved today. I'm hoping other delegates have picked up on the value add there as well. I think it's noticeable from Peter's presentation and from Mike's on the issue of dust. One of the things that strikes me is, as well as the explosion risk with dust, as well as the environmental risks, the health has often been the silent partner in health and safety, and the risk of dust to sort of long-term chronic conditions to the workforce is an issue for industries around the world. And I was just delighted to see that there is, these technological approaches that will allow control of dust, and the importance of dust management, both for explosive safety and the sort of protection of health for our people. I've noticed that somehow it's 14 months since the Beirut explosion, that the world has sort of hurtled along since. But I know that many people around the world are working hard to try and learn lessons and understand and prevent this kind of event in the future. And I think Mike's presentation clearly showed today that these kinds of large-scale explosions and fires are actually reasonably foreseeable. There's both a historical record and the smaller scale incidents that fortunately are mainly contained, but give you the base of the pyramid, the smaller scale incidents that tell you that it's a matter of circumstance that those could become larger scale, worse incidents. But I think the point is that these risks can be managed. Mike said we have a good system in ATEX or IECEX if used properly, and I think that proviso there is really important. And that takes us back to Peregrine's original initial presentation about managing the risks, understanding what your conditions and circumstances are. And again, Peter's presentation about intelligent approaches to dust management. It's not just a case of throwing the kitchen sink at it, but a targeted, managed approach. And that health and safety management is a continuing effort. A friend of mine often says that safety is a bit like riding a bicycle. If you stop pedaling, eventually you fall off. And I think this is what the message is, perhaps, that I'd like to leave the delegates with from what are three excellent presentations that we've had today. Thanks to Manos as well for stepping in to be there for Peregrine's session. I believe, unless there are any more questions, oh, hang on, some more chat perhaps. Let me just see. No, there's mostly thank yous. So I believe at that point, I will hand back over to the tech, or possibly Simon, I think, to close out the conference. Thank you.
Thank you very much. Thank you very much, Richard. Mike, do you want to say anything generally about the conference? Got any comments you'd like to add about the previous few days, or?
I think for me, it's been a great conference, as it always is. I've learned a great deal, a lot of stuff that I didn't know things about, and I think that's good. We had a good breadth of things, from health and safety to operations to digitalization and coordination and reducing emissions. I think we've had a great coverage, and it's, you know, it's thanks to Simon, who's worked so hard to get all the speakers. I think it's a shame we didn't get a few more delegates this year. That's unfortunate. I think, you know, we can see from experience people don't go to conferences online as much as they go to face-to-face conferences. But hopefully next time we'll be together face-to-face. And if the quality of the presentations and the content is anything like as good next time as it was this time, I'm sure it'll be a very good event. So I'd just like to say thanks to everybody for taking part, delegates as well as speakers. Obviously, without the delegates, there's no point in running a conference. But I'd especially like to highlight the hard work that Simon has done. Simon works incredibly hard for ABTO and for its members. And, you know, it's a bit of a labour of love for him. He doesn't make much out of this. But all of the members and other people in the industry have a great benefit from what Simon does. So I'd just like you all to just put your hands together for him. And that's, I think, about as much as I want to say. And I'll just hand back to you, Simon, for any final comments.
Well, thank you for those generous words. I would just like to add, if it weren't for the input that I received from Mike, it would be very difficult for me to do my job. He's an absolute tower of strength to me when it comes to putting these programs together. I mean, thank you everybody for joining us today, especially Richard for a very good moderation of today's session. Peregrine, of course, Peter, for all the way from Australia. Must be bloody late in your night, I would say now. And Manos, thank you for stepping in and joining us in Peregrine's absence. Thanks to Mike. Thanks to Ian Adams, of course, as well for dealing with all the technical issues, which would completely have thrown me, I think, and my other colleague Pat Wheater for editing some of the videos. Also, a big thanks to our sponsors, Badeshi, Igus, Buttimer, Samson, and Brooks Sowertel for supporting the conference and making it possible, and also a big thanks to our virtual hosts, the Freeport of Riga. I think Irina's still with us, and I had a tremendous amount of help from you Irina, and your colleague Andita for putting together our conference with your colleagues in the Port of Riga throughout most days of this conference. We had a contribution from your colleagues. So hopefully we will see you all again next year, and we very much hope to be able to go to Riga next year, assuming that the world is a healthier place by then. So, well, all that remains, I guess, for me is to say goodbye to everybody, and thank you for joining us. Goodbye for now until next year.
Thanks, everybody.
Goodbye and welcome to Riga next year.
Goodbye.
Thank you.
We'll look forward to it.
Very welcome to Riga. We shall be very hospitable and offer you a boat trip to the port, a nice networking cocktail with live music, an excursion to the old Riga. You will enjoy your stay next year. Stay healthy and see you next year in Riga. Very much welcome, gentlemen.
Thank you, Irina. Thank you.
Bye.
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 Thank you.
In 1922, Professor Heinrich Armund laid the foundation stone for the establishment of Armund, today a globally operating group of companies with innovative and customer-oriented solutions for the conveying and storage of demanding bulk materials. In conjunction with the headquarters of the product companies Armund Fördertechnik in Germany, Schade Lagertechnik in Germany, and Samson Materials Handling in England, the global conveying and storage technology business is spearheaded by locations in Europe, North and South America, Russia, India, China, Hong Kong, and the United Arab Emirates. Equipment for the conveying and storing made by the Almond Group of companies is used worldwide in the cement industry, the metallurgical industry, in power plants, ports and terminals, in mineral processing and mining, and in many other fields in which large volumes of bulk materials need to be continuously conveyed. Port installations, whether next to the sea or along a river, require the loading and unloading of bulk materials to be exported or imported. This is a domain for Samson mobile loading and unloading equipment. The Samson mobile ship loader allows vessels to be loaded at a rate of 2,000 tons per hour. In ports with only restricted space, the mobile loader may be moved away and stored between loading cycles. For the unloading of vessels, the Samson Ecological Hopper, or Eco Hopper, with its dust suppression system for environmentally friendly operations, fits into any installation, even those with a narrow jetty. Further areas with applications for Schade, Samson and Almond equipment are the handling and storing of any kind of minerals like phosphate, ore or potash. Handling alternative fuels and biomass, which are increasingly used in many industries to ensure sustainability, are also applications for Almond equipment. For all these industries and related logistics to and from the ports and terminals, the companies of the Almond Group design and manufacture innovative equipment to suit the individual requirements of the various processes.
Buttimer Engineering is a family-owned company founded in 1978 to serve the Irish agricultural industry. While building a strong expertise in bulk materials handling, it has grown into an international engineering firm, with project teams located in Ireland and Poland, serving an increasingly international range of clients. Buttimer Engineering is a diversified mechanical engineering company which specializes in advanced bulk materials handling systems. Buttimer delivers mechanical handling processes and projects for bulk port terminals, as well as agricultural and industrial facilities. The company's capabilities range from the supply of bulk handling equipment right up to full turnkey projects, including conceptual design, detailed drawing, procurement, installation, and project management. Buttimer can design solutions for ship loading and unloading, conveying, storage, product drying, and processing of a wide range of dry bulk commodities. Systems include pneumatic and mechanical conveying, storage silos, aspiration systems, and bulk outloading to trucks, rail wagons, and ships. Experts in handling dry bulk products, Buttimer frequently works with clients to deliver facilities where dust control, ATEX systems, and high-quality safety features are in place. These features include aspirated outloading stations, designed with environmental control features, minimizing dust and emissions during the handling process, integrating bulk handling facilities efficiently and cleanly with wider logistics networks. The company prides itself on delivering solutions that fully meet the customer's requirements, and the company's success is due to reliable project delivery and ongoing client satisfaction. In 2014, Buttimer Engineering launched Dock Solid, a bulk port equipment brand. The Dock Solid range of environmental and standard ship unloading hoppers has been developed by Buttimer over more than 2 decades. Dock Solid hoppers can be mobile, rail-mounted, or installed as part of a terminal building. Loaded with a crane grab, each hopper is custom designed to meet the need of the port, bulk product, and client. The mobile environmental hopper is an extremely robust and flexible unloading solution with state-of-the-art dust control features. Dock Solid hoppers are engineered in Ireland and fabricated in-house by Buttimer Engineering. They can be shipped to bulk handling terminals around the world.